Now we'll see how to find the Fourier series of the given graph. We know the Fourier series of f of x is equal to a naught plus summation n is equal to 1 to infinity a n cos nx plus b n sin x, where a naught, a n and b n are Fourier coefficients that we can calculate it from f of x is a naught is equal to 1 by 2 pi integral from minus pi to pi f of x dx, and a n is equal to 1 by pi integral from minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi integral from minus pi to pi f of x sin nx dx. So this is the given graph. Now we have to find f of x. Here, if you consider this graph from minus pi to minus pi by 2, this f of x is minus pi by 2. And from minus pi by 2 to plus pi by 2, it is a linear function. It is x, and then from x varies from pi by 2 to 2 pi, it is pi by 2. So f of x is equal to minus pi by 2 when x lies between minus pi to pi minus pi by 2, and it is x when x lies between minus pi by 2 to pi by 2, and it is equal to pi by 2 when x lies between pi by 2 to pi. Now you have to find the Fourier coefficient a naught. A naught is equal to 1 by 2 pi integral from minus pi to pi f of x dx. Now we are splitting the integral from minus pi to pi as minus pi to minus pi by 2 and minus pi by 2 to pi by 2 and pi by 2 to pi. And you are splitting this integral and substituting the various values of f of x, and then if you are integrating and then you are substituting the limit, then a naught is equal to 0. Next, for an, it is equal to 1 by pi integral from minus pi to pi f of x cos nx dx. Here also I am splitting the integral into 3 parts and I am substituting the value of f of x. And if you are substituting this, it is equal to 1 by pi minus pi sin nx by 2n. That is from substitute the limit minus pi to minus pi by 2. Then plus I1, I have taken integral from minus pi by 2 to pi by 2, x cos nx is I1. Then for the third integral, it is pi sin nx by 2n. Substitute the limit pi by 2 to pi. And I1 is minus pi by 2 to pi by 2 x cos nx dx. Here this is of the form integral u dv, and integral u dv is uv minus integral v du. Here I have taken a u is equal to x and dv is equal to cos nx dx. So du is dx and v is sin nx by n. So I1 is x sin nx by n. Substitute the limit minus pi by 2 to pi by 2. Then minus integral minus pi by 2 to pi by 2 sin nx by n dx. And if you substitute the limit, it is pi by 2n minus, if you substitute minus pi by 2, it is minus pi by 2n plus, if you integrate the second term, it is cos nx by n squared, limit minus pi by 2 to pi by 2. If you substitute this limit, it is equal to 0. So I1 is 0. So now you substitute this I1 in an, then an is equal to 0. Now you have to find Bn. So Bn is 1 by pi integral from minus pi to pi f of x sin nx dx. Here also we are splitting the integral into 3 parts and substituting f of x and integrating. And here I have taken I1 is integral from minus pi by 2 to pi by 2 x sin nx dx. For all other cases, it is pi cos nx by 2n and substituting the limit. So if you integrate I1, this is of the form integral u dv. Here u is x and dv is sin nx dx. So du is dx and v is minus cos nx by n. So if you substitute this I1 is equal to minus x cos nx by n minus pi by 2 to pi by 2 and plus integral from minus pi by 2 to pi by 2 cos nx by n dx. If you substitute the limit, the first term will be 0. If you integrate the second term, it is sin nx by n squared and substitute the limit minus pi by 2 to pi by 2. If you substitute this limit, it is equal to 2 sin n pi by 2 by n squared and it is equal to 2 by n squared if n is odd. For all other cases, that is if n is even, then this value is equal to 0. So Bn is equal to 1 by pi into 2 by n squared only for n is odd. So the Fourier series is, you know the value of a naught, an and bn. If you a naught and an are 0 and if you substitute the value of bn, it is equal to summation n is odd to infinity 1 by pi 2 pi n squared sin nx. So if you substitute the value of n, it is equal to 2 pi sin x plus sin 3x by 3 squared plus sin 5x by 5 squared and so on. So this is the Fourier series. And this also we can find by the inspection of the graph. It is an odd function. If it is an odd function, we can have only bn, a0 and a0 0. So if you, in that case, you can straight away you can find out bn and you can write this. So this is the Fourier series. Thank you.